Let's start with our first section, which is on rectangular coordinates. Basically, the big ideas that it touches on are the distance formula and the midpoint formula. Okay, if you've done those two things before, then you should know what's in this section. Okay, what the distance formula basically is it gives us a way to find the distance between 2 points on a grid. Okay, generally, we call the 2 points we want to find the distance between A and B. I've given them a coordinate. Okay, A has a coordinate x1, y1, and B has a coordinate x2, y2. All this means is like my first x, my first y, my second x, and my second y. Okay, we're gonna find the distance between the 2 points. Does anybody know what formula the distance formula really is? It's really another formula you learned in geometry, maybe before that, involving lengths of sides of a certain shape. But we just call it the distance formula when we use this formula with coordinates. But you know what formula? Okay, I'm going to draw a diagram and try to give you a hint. Anyone have a guess? Yeah? Not volumes, since it's only going to be one-dimensional. But good guess, because we're just going to be finding a length. That's a good guess. Okay, here's our picture. Okay, we've got 2 points, A and B, and I've labeled them just like I did up above. Okay, what I'm going to do to find the length between points A and B is I'm going to add a couple segments here to make a certain shape. Okay, what shape could I make if I add a couple segments in? And we're going to use this shape in pretty much all of trigonometry. Yeah, we're going to make a triangle. In fact, if you look at the word trigonometry, the first part, trigon. Trigon is another name for triangle. Okay? And you use that gon suffix quite a bit. Octagon, hexagon, pentagon. We usually don't say trigon. We say triangle. But you can. Okay? So trigonometry, trigon, and then metry at the end means measurement. Triangle, measurement. That's a lot of what trig is about. Measuring things in triangles. Whether it's sides, or what else can you measure in triangles? We're not going to do it in this problem, though. You can measure angles. Sides and angles. Let's add in 2 segments. One there, and one there. Now, I created a triangle, but I created a specific type of triangle. And I can make it a little bit more clear if I put that symbol in. What kind of triangle is that? Yeah, Sarah?
Right angle.
It's a right angle, which makes this a, what kind of triangle? Yes, Sean?
Right triangle.
It makes it a right triangle. Okay. And all that we're really interested here is the length of the longest side. And what's the name of the longest side in a right triangle?
Hypotenuse.
The hypotenuse. Okay. There's a formula from geometry that allows us to find the length of the hypotenuse, as long as you know the other 2 sides.
A squared plus B squared equals C squared.
Okay, a squared plus b squared equals c squared. What is that? The Pythagorean Theorem. Okay, that's all that the distance formula really is. It's the Pythagorean Theorem. Okay. All right, let's look at the bottom side. Right. Horizontal distances are easy to measure because they're on a grid, because they're in a straight line. Okay. The y values of this point and this point are exactly the same because they're horizontal. The only difference is in the x's. So this coordinate on the left has a coordinate of x1. Okay. What's the x coordinate of this point? It's not labeled, but based on another point, we know what it is. Yep. Yeah, it's x2. Okay, it's in a straight line with the point that's right above it. So if you have one point at x1, another point at x2, how would you figure out how far apart x1 and x2 are? Would you add those, subtract them, multiply, or divide them? You'd subtract them. Think if you had a number line. And you had a point at 2 and a point at 5, which we're calling x1 and x2. If you want to know how far away 2 is from 5, you just subtract. 5 minus 2 is 3. They're 3 units apart. Okay, so the length of this bottom side, let's write it down, is x1 minus x2. Or maybe in this case, x2 minus x1. But we'll see in a second, it's not going to matter. You might be thinking, well, wait a minute, what if you get a negative? It's not going to matter. Because you'll see why in a second. So that's the length of the bottom. If you wanted to be absolutely sure that it was positive, what's the thing in math you can do that always makes something positive?
Absolute value.
The absolute value. Again, you're not going to need that absolute value in a second. Okay? But that is the length of the bottom. It's the absolute value of x1 minus x2. Okay. And then the height. The length of the height. Well, the height has to do with y values, not x. Okay. What's the y value of that point on the bottom? It's not labeled, but it's exactly the same height as point A. It's y1. Okay. What's the height of point B? How high up is it? And that one is labeled.
Y2.
It's y2. Okay, so think of it as a vertical number line. This is y1. This is y2. If I want the height between those two, I just subtract them. Same way. y1 minus y2. And that's the hard part. Now you just use the Pythagorean Theorem. Okay, somebody said that earlier. A squared plus b squared equals c squared. But what they didn't tell me is what are a, b, and c. What's a and what's b?
Your legs.
These are the legs, yeah? And c? Hypotenuse. So, all we have to do is fill in for our legs. Okay? We know A. Let A be that. That's the length of one of your legs. Okay? Let B be that. So the reason you don't need the absolute value is because whatever you plug in for A, you're going to square it. Squaring it gets rid of a negative automatically. So you don't need to take an absolute value. Okay? Take any number you want and square it in your head. It always comes out positive. Okay? So now I'm going to write down the distance formula filling in to the Pythagorean Theorem. Okay? But if you know the Pythagorean Theorem, that's all you need. Okay? Let's compare it to what we just did. So I filled in x1 minus x2. And I'm going to square it, plus y1 minus y2, and I'm going to square it. So that part looks the same. But where did the square root come from?
So it's all positive.
So that's a good guess. So the square root is always going to come out positive. But why did I take the square root? Think about your Pythagorean theorem. We already know the length of A, we know the length of B. We really want the length of what? C. But we have C squared. Okay, this A squared plus B squared doesn't give me C. It gives me C squared.
Well, we can cancel out the c squared.
Yeah.
Have to square everything else on that side.
Right, that's where that comes from. So if you just want to know C, you need to take the square root of A squared plus B squared, and there's your distance formula. Okay, so a lot of times what we do in trig is we're going to look at a diagram and try to figure out where the formula comes from, and then we're going to use it. Okay, so our first example says, find the distance between those 2 points. Now the points aren't labeled, x2, x1, y2, y1. They're not labeled. Does it matter, which one is x1, which one's x2, and so on? No. Okay? Whether you find the distance from A to B or B to A, it's the same thing. It's like measuring the distance from here to your house or from your house to here. It's the same distance. Generally, what I like to do if I can, try to pick the numbers so that when you subtract, you don't get negatives. And you can't always do that, but I think in this problem you can. Okay. Notice somebody said it doesn't matter which one's x1, which one's x2. That's why it doesn't matter in the distance formula. If I do x2 minus x1 or x1 minus x2, it's not going to matter. It doesn't matter, because if you square something, no matter how you subtract it, it comes out the same. Okay, so let's start with x1. Okay, oh, and which number there could I let be x1?
4.
Yeah, sure. You could let that be x1. Now that he said that, everything else is automatically determined. That has to be x2. Okay? He could have made 3x1, and it wouldn't have made a difference. And now if 4 is x1, 5 has to be what? y1, yep. And this has to be y2. And now this is basic arithmetic.
You put a 2 on the y1.
Oh, thank you. Yep, thank you. Now you just fill in your formula, plug it in, and see what you got. Let's do it out. So you've got the square root of 3 minus 4, if we're going to plug it in exactly the way that formula says, plus 2 minus 5. If you wanted to avoid negatives, what I would have done is just switch which ones you're calling x1 and x2 and y1 and y2. But it's going to come out exactly the same. So, Emily, what's 3 minus 4? Negative 1, and then squared? Squaring, so negative 1 squared means negative 1 times negative 1. Just 1, yep. Okay, and Shelby, 2 minus 5 gives me, and negative 3 squared is 9. And that's our answer, square root of 10. If the problem doesn't say to give a decimal, we're always going to leave it as a square root. That's the exact answer. Okay, if you want an approximate answer, it's about 3.16. So we'll have to read the directions. Whatever the directions say, that's what you do. Top one's exact, bottom one's approximate. Okay, any questions on that? All right, let's try one more with the distance formula. Let's label the points just like we did last time. x1, y1, x2, y2. Okay, anytime you want to find the distance, start out, just draw a big square root, because you're always going to need that. And I'll stick with the formula, which is using x2 minus x1 in that order. Okay, so Amy, what's x2 here? 4? Minus Sam, what's x1? 2. Now we have 4 minus 2, Yadira, what do we have to do with 4 minus 2?
Square.
Yeah, we got to square it. Square it. Okay, Tom, what symbol comes right after this before the next set of parentheses? Plus. We're going to add. And now it's y2 minus y1. Brandon, what's y2?
10.
10? Minus. Ethan, what's y1? 6. And we square it. Okay, so we'll do that out. 4 minus 2 is 2. And when you square 2, you get 4. 10 minus 6 is 4. You square 4, you get 16. So I get the square root of 20. But there's something not quite right about that. Everything we've done is correct up till now. But what do I have to do with that? And this is an algebra thing. This isn't a trig thing. Yeah, Andy?
Well, you can break it down 4 times 5,
Yeah.
and then 4 squares to 2, so the 2 goes on the outside and the 5 stays on the inside.
Okay, so as she just said, you're going to factor 20. You're going to break it down into 4 times 5. Okay? Why not break it down as 10 times 2? This is a better way, I agree. Yeah, you got to have a number that's a perfect square for this to work. Okay? Your perfect squares are numbers like 1, 4, 9, 16, 25. Okay? So she factored it as 4 times 5. Once you factor it, you're allowed to split it apart as 2 square roots. Square root 4, square root 5. And if you picked one of them to be a perfect square, it simplifies nicely. Square root of 4 is 2. And the square root of 5 is as simple as you can get it. Okay? This is an important skill that comes up all year. Simplifying square roots. That's my main reason for doing the distance formula today. Not because I'm overly concerned about you finding distances between points, but because I want you to do this. Okay, any questions on that? Okay, so in the last problem I just explained, square root 20 can be simplified. If you need the steps on how to do it, you need to factor the radicand, that's the thing under the root. So that is the product of 2 numbers, like 4 times 5. One of the numbers you pick needs to be a perfect square. Then break the root into 2 roots, just like we did, square root 4 times square root 5, and simplify what you can. Those are the 2 steps for simplifying roots, if you need them. Okay, so square root 20, we already did that one. So let's try square root 48. I'm not going to go through a whole distance formula problem. Let's just pretend somehow you did the distance formula and you got square root 48 as the answer. Anybody think of how you can split up 48? And there might be more than one way. There's usually one way that's one step, and then the other way might be multi-steps. But if you do it right, you get the same answer each way. Yeah, Andy?
16, 3.
Yes, that's the better way to do it. Was anybody else thinking to do it that way? Yep. So you can write it as 16 times 3. And then take the square root of each part separate. Square root of 16 is 4. Square root's 3. Okay. Anybody else, were they thinking of a different way besides 16 times 3?
Yeah.
What's another way you can do it, maybe using a number we just used last time? Yeah?
Well, another number I used last time, but I did 8 and 6.
Okay, so you split it up as 8 and 6. Okay, and then what did you do from there?
I broke those down, and whenever there was a pair of numbers,
Yeah.
I
Okay, so that's another way to do it. You look for those pairs. Okay, you can do it that way. It's not the directions I gave, but that way works fine. Another way, you could split square root 48. Okay, just like a different way to do it is 4 times 12. Anybody thinking of 4 times 12? Yep. Now when you do that, square root of 4 is 2 times the square root of 12. The problem is, now you have to simplify square root of 12 again. Okay. What number goes into 12?
3 and 4.
3 and 4, exactly. So this 2 just kind of hangs out front. And then you split it up into 3 and 4. And then you can take the square root of 4 again, which is 2. So you have 2 times another 2 times the square root of 3. And 2 times 2, there's your 4. Okay, so if you don't find the biggest perfect square you can at first, that's okay. You can do it a couple times, and you'll still end up with the same answer, but maybe more steps. Okay, any question on that? Simplifying, so that's simplifying a square root. There's 2 things we need to know how to do with a square root. I'm not going to do both today. One is this, okay, reducing a square root. The other one is dealing with something like this. We won't ever leave square roots in the bottom of a fraction, so we have to somehow get this square root to the top. Okay? And there's a way we can do that very, very easily. Maybe even easier than this. Okay? So we'll talk more about that when it comes up. Okay, and the last formula we're going to do today is the midpoint formula. Okay, the midpoint formula, there isn't really a diagram to draw to really explain why this one's true. This one's more of a common sense kind of formula. Okay, it says to find the midpoint between A and B. You add the x's up and divide by 2. That's the first part of the coordinate. And you add the y's up and you divide by 2. That's the second part of the coordinate. One important thing to notice here is the difference between the distance formula and the midpoint formula. The midpoint formula, the answer is a coordinate. It's a location. With the distance formula, the answer is a length. Okay, so they're different kinds of formulas. Does anybody know what the name is of what you're really doing here? When you add 2 things together and divide by 2, there's a name for that in math. Take 2 numbers, you add them up, and you divide by 2. It gives you the something of the 2 numbers. It gives you the average. That's all the midpoint formula is. Average the x's and average the y's. Gives you what's right in the middle. Okay? There's no square root in this formula, so you don't have to worry about reducing square roots. Okay, the only thing that you might get is a fraction. If you had an odd number, you can write it as a 0.5 if you want. Like if you end up with 3 divided by 2, you could write 1.5. Or you could leave your answer as 3 divided by 2. Either way is fine. Okay, first, before we start it, I'm going to ask the same question I did with the distance formula. Does it matter if I do x1 plus x2 or x2 plus x1? No. When you add 2 numbers together, it doesn't matter the order you add them up in. It's commutative. Okay. All right, so let's just start by writing down what we're going to have for our formula, then we'll do the calculation. Okay, Naisha, what is x1 here?
3.
Sure, could be 3 or it could have been 7. It's not going to matter. So since you picked 3 for x1, that makes 7x2. Okay, how about Lydia, what's y1?
7. No, I got 4.
Yeah, if we're going to do it the same way we did before, the first coordinate we had be y1. Yep, so that's 4 plus y2 is 13. Okay, don't leave your answer like that. Simplify what you can. Okay, so how about Andrew? 3 plus 7 gives me 10, and then divided by 2. Okay, so the x part of the midpoint is 5. And the y part, Kyle, 4 plus 13 is 17. Divide by 2. Or if you wrote it as a decimal, go ahead.
8.5.
Yeah, 17 divided by 2 is 8.5. Okay, questions on that one? So that's your distance and midpoint formula in 2D. Okay, later in the year, we'll extend the distance formula to 3D. It's a very simple extension. You just add on the z's, the z component. But for now, we'll stick with 2D. Okay, and for tonight, chapter 1 in your book is all algebra review. It's not trig. So I just want you to look at page 7. 15 to 21 odd, that's your distance formula. 39 to 43 odd is the midpoint. And I want you to simplify those 4 square roots.